Hello, this is an informational video that is directed to any new hires or anyone that wants to get a better understanding of the full flow of a charging site, okay? So always there's going to be the panel, the main distribution center. There's always going to be 3 doors. Let's start even more than that. There's always going to be a transformer. And so this is where FP&L in Florida, you know, your electrical company in your state has high voltage either on the lines or underground. 4160, 4160 volts is usually what it is, coming into here, which is then stepped down through a step down transformer to 480 or 208 or 120, 240. Now, in this case, it's 480. So it's going to be 480/277 or 208/120 or 120/240. This is 480/277. Now, 480 is very dangerous. 3 doors. 1 door is going to have the main breaker. 2nd door is going to have the branch breakers. 3rd door is going to have the little circuit breaker panel, which now for BTC, a lot of them need the 120 volt circuit breaker panel because that feeds stuff for the actual chargers. The other brands don't, but there is a panel always in here, and the main feature is that there's a outlet that's installed. So let's look. This is, like I said, very dangerous. You always need to have your protection. This is where that you're going to be wearing your fire rated protection, goggles, gloves, and everything. When you're opening the door, you always open away. Never stand in front of it and open right in front of your face. Very bad habit. So this is the main breaker. This is what someone refers to as the main breaker. Okay. Main breaker. Let's close the doors as I show you them. So middle door always has the branch breakers. So branch breakers, labeled unit 2, 3, 4, 1. There's always going to be either like a transformer breaker, there's a GFI breaker, and sometimes there's extra breakers that just aren't even turned into the on position. So keep that in mind. Let's close these doors. Branch breaker is what that is called, and it's referred to as the main distribution panel because it's distributing power. Transformer from your utility company sends in the wires to the main breaker. That can be turned on and off. Any breaker can be turned on and off so that you can service downstream. So that sends the wiring to your branch breakers. So there were 4 of them, right? We saw 4. There were more, but 4. 1, 2, 3, 4. Each branch breaker is going to feed the a power, a tower. And like I said, just a regular outlet that you would see at your house. Outlet available. Oh, regular panel like that you would see at your house. And then, like I said, regular outlet to plug into. These sites always have the locks. Always make sure that they're locked when you're done. This is always the lock box where they hold the keys for the site. It'll always be on site somewhere. So the 4 branch breakers are going to have the wiring fed underground to each power cabinet. Like I said, always open away from you. So, and these, all the brands are going to be a tad bit different, but they all have the same stuff. So these are your power modules: 2, 4, 6, 8, 10, 12. Not all of them have to work. And if some don't work, what that does is it doesn't allow this thing to charge as fast. It'll derate the charger over there. So let's go over this. We've got the wiring coming underground, feeding right here. That's a 480 volt designation coloring. It's going up here. Breakers, just, oh, that's a contactor. Those will open and close as it's directed through the computer over there. It'll send a signal to open, close, blah, blah, blah. So that's allowing power through or not. Then it's being fed up. That's what's called the bus bar. It's hard to see. It's hidden back there. It's basically those metal, it's like not wiring, it's those metals. They're all color coded. Normally some aren't, and it's just like the metal. That's a bus bar. So we've got 3, 3, 3. It's feeding every single one of these. The job of these is to change the voltage from AC to DC. Alternating current to direct current. DC is what the charger and the car needs to charge. So when it's changed from AC to DC, so it's going in as AC, it does its magic, comes out as DC, and you'll have a positive and a negative for DC. That's why you have white and red, white and red, white and red. Then that goes on to the DC bus bar, brought all the way down here, which is then fed to the wiring that's going to go into the ground over to the chargers. These have tons of fans because it gets very hot in here. Fans right here too. You've got 3 on each module. You've got 2 big ones here also to help the airflow, right? These are transformers. They're going to change voltage from 480 that's brought in to 12 or 24 volts DC. And let's take a look here. So look on the sticker. It says 200 to 480 for input. Output is 24 volts DC. So we were right. Fuses, more fans. This is the fiber optics with the 2 in there. You can see them being held. And that's about it for right here. So that's that, right? And so once it changes from AC to DC, it comes down here, goes into the ground. Let's see where it goes. Make sure you're always locking those up. So don't want to have any names in the photo, so that's why I'm showing you the ground. Anyways, this is the new 350 kW hyper fast. So let's make it so that it locks the door, stays open. HMI Nayax cardless reader. All right, so we found the wires that we literally just showed previously in the video that's coming underground, coming up into here. Okay, we see that we've got the I always forget that word, but the fiber optics right there. I will get to this in a second. Anyways, let's go over the path flow. We got DC cables coming in, fed to right here. That is when it changes. Well, it's still DC, but it goes to a liquid cooled cable. And that's what this white one is. So you see you've got black and red. On the bus bar, the copper where that bolt is right there, you see how there's red? So you've got black and red. And on this new charger, the wiring goes bam, in, and out that, which is gonna come to the wire where you will plug it into the car. Now, we've got the brains. That white box is basically your CPU, which powers the, not powers, but is, you know, the HMI. It's basically Windows 7 with a program that a company will use, which is what you're using, you know, to go through the screen. Like literally, this is Windows, that you will see the Windows icon and all of that, programs, but there's a program open. If we close this program, it's going to show you Windows. Anyhow, we've got the modem, CPU, all of that. SIM card goes in here, you know, that's how we're getting our signal. We've got our fiber optics connection there. We've got more circuit breakers. So we've got another transformer, 480 volts, and changes it to 12 volts DC, which is then fed throughout the system to power the circuit boards and all of these other little accessories. We've got multiple circuit boards. There's the MCU. There's so many things for each charger. Look, MCU written right there on the circuit board. That's the MCU. We've got an EVCC or the SECC over here. Now we've got this, which is new. It's going to actually give you the option of showing you different settings like voltage, amperage, the hertz, the wattage, all of that. So now let's look at this right side. There is coolant inside of these. Every charger is going to have a coolant line, and what that is, like I was telling you, that white line, these cables right here is where they turn into liquid cooled cables. And that's to keep the cables cool when they're charging the vehicle, because it gets very hot. And so what it is, we've got, this is a motor. It's a pump basically. And it circulates the coolant. Okay? So basically, and then there's a coolant reservoir that holds the coolant back there. You fill that up, pump is running, it's circulating the coolant through your evaporator. You've got an input and an output for your coolant lines. Let's say the hot coolant's being pushed in here. We've got fans right there and right there. Those are blowing out, right? So we've got coolant going through each one of these little coils. And then we've got fans blowing air through. Even ambient, regular room temperature air is going to cool these down as they're going through each coil. And so it goes through each one. It goes from, you know, 200 or 250 degrees back down to say 180, 170. It's nice and cool, and it comes out and flows back into the copper wires that are liquid cooled. So yeah, I mean, now you kind of have an understanding of everything. You know, PC board, we've got the modem, SSD for memory, little breakers here that are gonna see 480 volts coming in, 480 coming out, transformers, more fuses, and yada yada yada. And that's how it all works, folks.